Okay, we're gonna try and see if we can't fix this old CRT TV. The owner's complaining that the VCR slash AV input isn't working anymore. Okay, well we dug up this old VCR and there's definitely nothing showing up on screen. Okay, so right away we found that the AV input sits on this little module here. So we tried popping that off and putting it back in to see if maybe a bad contact was the issue. But apparently it isn't because it's not changing anything. And right now I've actually got my little signal generator here going. Got it hooked up directly into the RCA input. And it must be a very low impedance input because when I hook it up, it drowns out the signal generator. Either that or something's wrong over here. I'm not sure if that's normal. I'm actually feeling something feels hot right here. This little diode feels a little bit hot. Okay, and the problem is definitely going to be the module because I removed it, and when I touch over here, I don't know if you can hear that. So when the audio goes into here, it gets amplified and gets to the speakers and everything. And over here on the module, you can see right there, that looks pretty crisp, and this resistor is pretty hot. So something definitely wrong with this module. Let's see what's going on in here. So this module actually gets the power through this cable right here, and then this diode right over here, because it comes in as AC, and this diode right here rectifies it, and then this resistor and this Zener combination right here set the voltage to about 13 volts. And it might just be that the resistor is dissipating a lot of the heat, a lot of the energy to bring the voltage down or something. AC input is about 8 volts and DC output is about 13 volts, so I don't think that's the case. Not totally sure though. But neither of these feel hot or anything that would indicate a short or anything like that. So let's see. Okay, as it turns out, these two things, which I thought were op amps to amplify the incoming signals, are actually optocouplers, and I imagine they're being used to somehow switch the inputs on and off or whatever. But I'm gonna go ahead and check around these guys here and see what's going on with them. One's a TLP 651. Here's the internal diagram, and I guess what I'm gonna do is I'm just gonna first of all measure the voltage at this point right here and see if it's feeding the LED and if it's turning on or whatever. This is connected directly to the B plus of this board, and this is connected to a transistor which seems to switch it to ground to turn it on and off. And I'm also going to measure the rest of these voltages, but basically I'm also going to check, this is probably going to be the other most important point right here. I'm going to check whether or not this is measuring 0 or whatever this is measuring to see if this transistor is actually turning on. It's weird though because this actually has a voltage input to the base directly. Usually optocouplers don't have that, so I don't know. I also don't know what the deal with this diode here is. Maybe if this thing was meant to switch relays or something, maybe they included that for... Actually, wait, that doesn't make sense because that's at base. I'm not really sure what the deal with that is, but I already checked the optocouplers with my multimeter, and I do get some a reading between these two, which on a normal transistor shouldn't happen, but I imagine it must be something else in the circuit that's doing that. Same thing goes for this one. So what I did is I went and sort of found where this is hooked up, and there's a small resistor, and that resistor goes to a B plus line, well, a voltage line. There's actually a transistor as well here. I think that transistor probably turns on when this is high, when this junction here is high. But I think basically the voltage that's supposed to go in here is missing, and I'll try and show you that. Okay, so pin 6 here is the collector of that optocoupler, and when I measure there I get negative 0.40, which is weird. But I mean, that would make you think that this is probably turned on and conducting to ground. And when I go over here to this resistor, which is what connects to the collector, on this side is where we get that 0.40. So what I would expect, and this is I think 15K, so I would expect voltage on this side and this side low because of the transistor being turned on. But on this side I actually also get negative 0.40, and if I follow this line, it comes all the way down, goes through this, same negative 0.40, same thing here, and basically it comes down all the way to here, to this pin right here. Right here is a capacitor, an electrolytic, and so it's got that negative 0.40, so it seems like this voltage right here is missing. Okay, if you look back here, I think I may have found the problem. If you see, there's this resistor right here. This side connects to pin 1, which is where that negative 0.40 is being read, and where I think some voltage should be appearing. And if I measure this side, it's 0 volts. We're not getting negative 0.40 because the module is missing. But if I measure the other side over here, there's 15 volts on it. So that's obviously open. Okay, so here's our resistor. And as you can see, multimeter says infinity. Not sure if that's a 7 ohm or if that's a 5 ohm, or I mean 2 ohm. So, but I mean, either case, it's a very low value. And usually when those things, when there's a short on the other end of those things, they usually end up acting like fuses and they go open. So I'm hoping that didn't go open because there's some kind of a short on the line that it connects to. Okay, so here I'm measuring across that pin and ground, and there's not like a dead short or anything like that. I think what we're reading there is like a transistor or a diode or something like that. But either way, no short. Let's try and replace that resistor and just see what happens. I don't even think I have any resistors of that value, but we'll try and see. Okay, the closest I could get was this 15 ohm resistor. I guess it's good for testing purposes. It's high wattage, so you know, if there's any problem, it'll take a good beating. And let's just see what happens with that. Alright, well, here it goes. Let's see what happens. I'm measuring the voltage at the same time over here. Oh, whoops, that's not voltage. There we go. That would have killed this multimeter. But okay, let's see at the 20 scale. Turn this thing on. Okay, we're getting voltage this time. And resistors feels fine, so that may have been the only problem. Okay, now if I hook up my signal generator, you can actually hear it through the speaker. So let me hook up a signal source and see what happens. Okay, I got my VCR hooked up here, but I'm still not getting anything. No video and no audio. So here's the base of this transistor. And we're going to inject audio signal right into its base. So you can hear it at the speaker. So basically when you inject the signal into the base of this thing, that modulates the LED inside the optocoupler. You can see when I touch it here, you can faintly hear it. But over here, obviously, it gets amplified. Okay, so I take that back. There actually is audio now. There is audio. I don't know if there was a bad connection or something, but there is audio now. But there still isn't any video. So it's just the audio coming out of there. Okay, again, I apologize for the crappy shot, but you can see there's nothing on screen. All you can see is like a weird pattern thing on there. But here's the audio coming through. Okay, so what I'm trying to do, considering the audio channel is working and the video channel isn't, is I'm trying to compare and contrast the two. And they're both set up fairly similarly. And I'm trying to use my signal tracer to do that by basically finding where the signal comes out through the other side of the optocoupler. And I found out the signals come out of the collector of the transistor that's in there. So for example, here on the audio channel, when I touch my signal tracer,